In this video, I'd like to demonstrate how to generate a flux map, pathway map, to analyze it as a network with two programs that are freeware. The first is NodeXL, and you can see NodeXLCodaplex.com, and Gephi at gephi.org. So we'll start first with NodeXL. This becomes incorporated right into Microsoft Excel, as in the indicated in the last part of the name, and it has many conveniences. And the Gephi is a standalone that seem to have a few more dynamic features, but we'll see that there's kind of a challenge as to decide what's good for this or good for that. This presentation is really for probably lower level skilled people, as myself, and maybe undergraduate students. Those more sophisticated can probably set things up more dynamically with larger programs and possibly not even need these, but I thought this would be helpful. So I'm going to first go to the NodeXL, and when you download NodeXL, you get a template to work off, and I'll just open that so you see the template here. So it opens into Excel. So you get two panels, this graphic panel to show your graph. It may be incorporated into this window. I drag it out. You can see that it can go in or come out. I've got it preset to a size that I like, that when I save it as an image, it's just about right. So those are little subtleties that you work out along the way. We notice that on this page, this worksheet edges, we have vertex 1 and vertex 2. If you hover, you get information about them in various columns. And then the vertices, here we just put the vertex. This will be just our reactants in our biochemical pathway. In this case, it could be a signaling pathway. Simply a list of them, and as we'll see, the standards. Color, shape, size will be determined by some of the values that we put in. There's a label. The label fill and label position will be determined through the features of the software. And then you can add other bits of information, and you'll see what we add here in just a moment. So now I'm going to open the one that I had set up previously myself. Notice that the graph does not show up here until you click the Show Graph, but I want to demonstrate the spreadsheet first on the left before going to that showing of the graph. Again, we have edges, which are our, if you will, reactants, the left side reactants, substrates, right side reactants, the products. In the columns here, again, these values were determined by a function that I'll show you in a while, determined by different values. Here are the acronyms for the enzymes. I typically will use the gene symbol because I want to illustrate the change in gene expression in this map as well. I put in the reaction name. I use Kapasi modeling, and those are the reaction names in the Kapasi to run the simulations that give me my flux values, and then I compare one treatment to another. In this case, it was water stress. Trehalose is a very important complex carbohydrate in water stress in plants. So you can see the range that we have here from -6 to -13, and I tried to come up with some scalar quantities that would be representative of that. When we see the graph, that'll make a bit more sense. And then these are the changes in the gene expression for the genes of these enzymes that we saw here. These are the labels. Again, you'll have to add these. So These are my scalar labels. To the left is the change in the flux value. To the right is indicating the scalar change in the gene expression. If I expand this, you just see what I have in there. Flux differences. So it works just like Excel. So it's very nice. You can add positive and negative values. You can change these very easily, as we're accustomed to. Here under the vertices, we of course just have our list of reactants, as I said, and then the list of the scalar labels as species in your reaction, or reactants, as I said, in order to have them graphed to your illustration. And then we have the changes in in this case, the percent difference between the water stressed. And then we can assign pathways. You can put different pathways in here, and it's a very powerful system. I'm just doing a simple one here. I need to show you one other part before we leave this. You can have it do all these calculations, but again, we just want it to map only what we want. The position, you will determine that by the mechanical layout in the graph window, and to make it look like a biochemical pathway, and minimize white space and maximize text size for publication and presentation. Here we have our label. I should stretch this, and you see label position. You don't need to worry about these two columns. Those again will be determined by what the mechanics basically of what you do in the graphic window. But you do need the label for these, so it doesn't automatically look here to get this information. Then the final setting that you want to work on, and I discovered this, I like the sphere the best. Again, the size and the color are going to be determined by the values out here. Now let's just take a look at how we assign those values before we go to the graph. You probably would go to the graph before you would do this with a new model. And again, you can set up all this information in, actually what I do is I open my Kapasi model and I just copy in the reactions. I fill in this information and the reaction name and the gene or the enzyme that's responsible for it. I typically will have that information in the title of the reaction. It's just a slightly different case in this because we're looking at rice, and for some reason they don't use gene symbols. Anyway, just peculiarities with the system. If it was human system, in the name of my reaction, I would have the gene or genes assigned to that reaction listed in the title, so I would just copy it from here and paste it there for my label. So now up here we can see in the menu for Excel, NodeXL has been added, so we click on that. If I maximize, you just get to see how they look there. I come up here on the far right to restore it back to this. This graphic window, you can move it around and stuff, but I prefer just to leave it there. Visual properties is what we're after, and we want the auto fill the columns. And I have these preset, so you can see that the edge color, again, the edges are the arrows for the reactions. The vertices are the species. You see the species level is different. So you simply just select the column label of the variable that you want to use to determine this. There are options. The standard is green down and red up. I wish this would let you force it to have white or yellow as 0 to meet that standard. This is where setting up your low and high scalar based upon the data ranges that you have becomes important to have this separation, to have a 0 change fall somewhere in here. If the programmers ever get to watch this, I hope you listen to me and put that in there for this very important function. You can have it go to the smallest to the largest. You can play with it here and swap colors and things of that nature. So it's very flexible. Ignore outliers and use logarithmic mapping. We're pretty much going to go linear. Again, it would be nice to have the option to fix it in the center at a 0 with a certain color, and then have that color gradate maybe, or just start the gradations, I guess, red going up. But anyway, we can't change those things. But by setting your scalar quantities, you can work up and down to get the desired effect. If you have a scalar quantity of 0, like the no change, and your proper negative and positive changes, the vertex size is going to be the same. We come here and smallest to largest, and then you can set this. Once you have your graph going, you can change these. You click the OK, and it applies it. The graph automatically refreshes, and so you just play with this range to see how it works with the range of your scalar quantities, and the actual quantities is what you're going to play with to get that. Edges are the same. I use gene expression change to determine the color, and again use the standard of green to red, and you have the same type of stuff to play with here. If you were assigning color to your pathways, say you had sucrose biosynthesis pathway, you could use the categories, but we're doing numbers. And then the flux differences for the width of the arrows, and again you have this flexibility to work with things to get the opinion. Now what I like about this is you have your spreadsheet here very nicely. This floats in a window. You can go into your spreadsheet, do what you need to do. You just need to size it for your monitor. I have a pretty large monitor, and then you get to see what happens on the graph. First thing I want to show you on the graph, once you get these organized, you can click and drag. You can highlight to select the two, and then they'll move together. A variety of things like that. Most importantly, when you get it where you want it, let me just finish bringing it on the screen here. Right click, select all. I just select everything, and then you go up here, lock the selected vertices. What's very flexible about this software is you can right click and remember which is an edge and which is a vertex. The vertex is the species, the sphere. And so you have you can control some things here, and notice the label position. That's very important. In the other software, the Gephi, you'll see that if you can do it, I haven't been able to discover it so easily. So the user interface with NodeXL is quite nice. Just spent an hour or two clicking around, and I discovered most everything I needed. Another is up here, graph options. If you're wondering how to change your font size, you can look at these are global effects, of course. You can play with these, but the defaults seem to work very nicely as I set up everything else based upon my scalar settings and things of that nature. Here you can click on this. You can work with these if you want. Mostly I came here just to change my font, and you have all of these flexibilities in here. And then you click OK, OK. I'm clicking cancel, as you can tell, and OK, and then that predetermines it. Note that I'm still selected on here, so they're red. It's very important to click away from that. And then when you come to this again, obviously there's many other things. You can play with them. This is where we save our image. And I'm going to get our folder first here. This is NodeXL, Trialos. And I want to save it. I'd save it as a TIFF because that's easier for me to work with. You can name it whatever you want. Now when we go into our folder, we have a TIFF file in there. You can open that in Adobe Photoshop. You can insert it into Microsoft Word. You can get the wrong, that's Gephi. NodeXL, Triolos. And so you can work with it in